Question 13, part A, we've got to do a binomial expansion of this expression here in ascending powers of x. And I've put here the formula which is in your formula books, and we've just got to fill in the blanks. But we've got a problem. We've got a 3 here, not a 1, so I need to get rid of that 3. So if I take a power of 3 out of the expression, let me keep it all raised to the power minus 2 for the moment, I get 1 minus x, plus rather, x over 3. Multiplying this out, let's just check. Yes, I get 3. Yes, I get x. We need to get the 3, which is now to the power negative 2, out of it. So I can say this is equal to 1 over 9 of 1 minus x. I keep writing minus, plus x over 3. And this is raised to the power negative 2. So that's our expression. We can expand this bit and just keep the 9th outside all our calculations. So this, when we expand it, will be approximately equal to a 9th, big bracket, and now I write an awful lot of numbers substituting n is equal to negative 2 and x is equal to, or the x in this expression is equal to x over 3. First term's easy, minus 2 multiplied by our x, which is x over 3. That's the first two terms. Now the next one, it may not remain positive for long, so I get negative 2, negative 3, n minus 1, over 2, multiplied by this term squared, which is x squared over 9. That's all they want, but yes, it does go on. Tidying this up and popping the 9 back in, I get a 9th minus 2x over 27. Now, is it going to be plus or minus? It's going to be plus. That 2 cancels with that 2. We get a 9 times 9 on the bottom, and we get 3x squared on the top. So this is 3x squared over 81. And a further simplification, 3 will go into 81. And that should be your expansion to 3 terms. So in part B, we've been asked to use our approximation for the 3 plus x raised to the minus 2 to answer this definite integral, giving your answer correct to 4 significant figures. So what's different about this? Well, what's different is that we've got 6x lots of this guy. So I can write that our integral from 0.2 to 0.4 is 6x multiplied by our expression here. So multiplying this out, I get the integral from 0.2 to 0.4 of 2x over 3 minus 4x squared over 9 plus 2x squared over 9 again. 3 separate terms. The integration is relatively simple, and it turns out like this. So after a lot of calculation, you'll find that the answer is 223 over 6750, which to 4 significant figures is 0.03304. And that's your answer to part B. Part C, we've actually got to do the integral properly. This is an expression really in x squared, and we do have the differential on the top, which indicates we can make a substitution of 3 plus x as u. But in doing that substitution, we have to change the dx and we have to change the limits. So my substitution, let, therefore, du dx is equal to 1. And further, I can say that du equals this. So we don't have to, other than change the letter, we don't have to do anything here. So here are the limit changes. 0.4 changes to 3.4, 0.2 changes to 3.2. And I also should write probably up here that x will become u minus 3. So there's our kit of parts to change the integral. So our integral becomes the integral from 3.2 to 3.4. 6x will be 6u minus 18 on the top. divided by u squared, and this is du. And that will happily split into two terms. Hopping up a line because I'm running out of space. Do the integration. This is 6 ln u. 1 over u integrates to ln u. And now looking at the next expression, this is u to the minus 2, which when we integrate becomes u to the minus 1. The sign changes and we get plus 18 over u. So first of all, substituting 3.4 and then subtracting the substitution of 3.2, we get, subtracting logs, we can put these two log terms together. So this becomes 6 ln 3.4 divided by 3.2. Then the other two terms, if you put those into a calculator, turn into 45 divided by 136. Oh yes, we could multiply these two guys up to 17 over 16 if you wanted integers there as well. But that's a perfectly good answer.